Hello everyone. In the last video, you learned what is hashing, hash table, hash function, different types of hash function, characteristics of good hash functions. Now we'll go ahead with the concept of collision. The hashing is give you a searching time, insertion time and deletion time in a deco of 1. So that is a most efficient searching time or insertion or deletion time. But there is a major problem with hashing is the collision. So let us see the collision. When two or more keys map to same address in the array, then there is a collision. Hash collisions are practically unavoidable. All hash table implementation have some collision resolution strategy to handle such events. By choosing a good hash function, you can reduce the collision, but you can't remove collisions. So let us see the collision resolution techniques. There are two main techniques. One is open addressing and second is a separate chaining. Open addressing is divided into three types: linear probing, quadratic probing, or double hashing, or you can say a rehashing. And separate chaining is a use of linked list for handling the collision. In open addressing, the same hash table is used for addressing. Open addressing, it search for open or unoccupied place in the hash table where colliding elements can be placed. To search an open unoccupied place, there are different techniques. One is linear probing, second is quadratic probing, and third is rehashing or double hashing. Now let us see the first technique for finding the empty space in a hash table, that is linear probing. As the name suggests, it searches for a next empty slot sequentially. So whenever a collision occurs, next empty slot is obtained by sequential scanning. So hash of any key plus I mod size is used for searching the empty slot. The value of I is varying from 1, 2, 3, 4, 5. The main problem with linear probing is the primary clustering. It takes more time to find an element or to search an element as well as to find the free slot in the hash table. Let us take an example and understand it. Suppose if you are inserting the elements one by one. So let us see the effect in the hash table. So first is insert 76. 76 mod 7. Here the size of the table is 7. So it can occupy maximum 7 elements. So 76 mod 7, it is answer is 6. So 6 is the index in the hash table. This is your hash table. The 6 is the index of the hash table, and now this 76 is inserted at the location 6. Next, 93. 93 mod 7 is equal to 2. So 2 is the remainder after dividing 93 by 7. So at the location 2, you have to insert 93. So 93 is inserted at the location. The next is 40. 40 mod 7, it gives you the value as 5. Now let us see the location 5. It is empty, so you can add the element or you can insert the element at the location 5. Next, insert 47. Now here you will get the hash value as 5. and the hash value of 5 is already contained the 40 as an element. So here the collision occurs. So 47 and 40, both the key maps to the same hash value and the collision is occurred. So when the collision is occurred, you have to look for the next empty slot in a hash table. In the same table, you have to find out the empty slot. So after the 5 plus 1, that is 6, is not empty. Plus 1 is 7. 7 mod 7 is 0. So it's always a circular table. Hash table is a circular. So you have to again start with the index 0. Now this index 0 is empty. So you can insert 47 at location 0. Now insert 10. It is mapped to the index 3. Now let us see whether the 3 is empty. Yes, 3 is empty. You can add the 10 element at the location 3. Now 55 mod 7 is 6. See the location 6. The 6 is already occupied by the number that is 76. So this is a collision. So whenever there is a collision, you have to search for the empty slot. So you will get the empty slot after the 0, that is 1. So you are here 76. After this you are at the location 6. 6 plus 1, that is 7. 7 mod 7, 0. 0 plus 1, that is 7. Now 1 is the free slot. So you can add the 55 in the empty location. So this is the example of linear probing. Now next is a quadratic probing. The problem of linear probing is the clustering problem. So instead of generating the linear sequence, can we generate the random sequence or a quadratic sequence? So we can do that using this formula. You have to calculate the hash of the key plus I square. Instead of I, you have to take the I square mod size. That is, I is ranging from 1, 2, 3, 4, 5. For example, your hash key is 1. So 1 plus 1 is 2. Then 1 plus 2 square, that is 4. So 4 plus 1 is 5. So you are searching for the empty slot at 1. Then you are searching it for 5. Then so on. So you are not searching the empty slot sequentially, but you are searching it in a quadratic fashion.